Assalamualaikum and hi everyone. Today we will be going through the intersection of sets. This is Mathematics Form 4 Chapter 4.1. First, let's do a super quick recap on sets. Sets are a collection of distinct objects forming a group. The objects in question can be a collection of numbers, days of a week, types of vehicles, etc. The objects in a set are written in curly brackets over here. Examples of sets are sets containing numbers from 1 to 6, or it could be a set of characteristics like clumsy, attentive, sharp, and friendly. Then this would be a set of characteristics. It could also be a set of animals where the objects are animals like cats, dog, and panda. Intersection of sets occurs when two sets or more have a common object. The intersection of sets is written using the symbol that looks like an upside down of the letter U over here. The complement of an intersection of sets is written using this symbol, which is just an apostrophe. The complements of the intersection of sets, A and B, which can be written like this, refers to all the elements not in the intersections of sets A and B. The intersection of sets can be illustrated using a Venn diagram. For example, the intersection of P and Q can be shown by shading the region where the two sets overlap, because the overlapping would mean that's the part of the set where they have a common objects. Hence, the shading would look like this. Same goes for the next diagram, and it is also good to notice that Q is actually a subset of P, meaning that the whole set of Q is actually an intersection between P and Q. That's why we shade the whole set of Q. The same concept is also applied for the next question. Even when there's shown as necessary, since the question only asks for P and Q, we would only look at P and Q. The shading of the intersection would then look like this. The final question involves three sets. As usual, we would only look for the part where all the involved sets overlap, as it represents their intersections. Hence, the shading would look like this. Now, let's move on to some examples to see how it is used practically. You can go ahead and pause the video if you want to try the question out for yourself first. Example question 1, the Venn diagram shows set J, set K, and set L such that the universal set contains 1, 2, 3, and up till 9. List all the elements of the following intersection of sets. The intersection of sets between J and K, J and L, K and L, and J, K, and L. For J and K, how I would recommend doing this is by first listing down all the elements in the sets involved. In this case, in J there are elements 1, 3, 4, 5, 6, 7, and 9. And for K, there is 2, 3, 5, and 8. The next step is to highlight or list down or just take note of all the common elements these two sets have, which in this scenario is 3 and 5. So the final answer is 3 and 5, written in a curly bracket like this. For the next question, the same method applies for intersection J and L, which is list, highlight, and state your answer. The intersection of J and L has the element 5, 7, and 9. It is again good to notice that L is a subset of J. That is why all the elements of L is the intersection between sets J and L. For the next question, the same concept applies again. List, highlight, and state your answer. So the answer for this intersection is 5. For the final question, it is asking for the intersection between J, K, and L. Similarly, if you follow the same procedure, you just list down all the necessary elements, highlight, and state the final answer, which is 5. Another method to do all of this question is to, of course, just look at the diagram directly and pick the elements based on the overlap sets. However, sometimes the diagram is not given, and drawing the diagram can be more difficult than just listing down the elements manually. In my humble opinion, I would just suggest for you guys to try to do both every single time, just so you can be good at it. Moving on to example question 2, they are asking us to shade the regions that represent the given set. We can see that the question is asking for the complements of intersection. Reminder, the meaning of complements is that the complements of the intersection of sets A and B refers to the elements not in the intersection of A and B. For the left one, we already know the intersection of P and Q. Thus, the complement of such intersection would just be everything besides the intersection itself. Hence, the shading would look like this. Apply the same concept just now for the middle one and the right one as well. We first identify the intersection, then shade everything except the intersection of sets. And the final answer would look something like this. Example question 3. A badminton club organizes a competition among its members. A total of 38 members are involved in this competition. 20 members play in the double event and 26 players play in the single event. Calculate the number of members who play in both events. Now, this is the type of question where there are no diagrams or elements of the sets given. What I would do first in this situation is to set some parameters so it is easier to write and understand, which is, I would let the universal symbol be the numbers of members involved in the competition, and let D be the numbers of members play in the double event, and let S be the numbers of players playing in the single event. What does the question actually want? It is asking us to calculate the number of members who play in both events, meaning the number of elements for the intersections between set S and D, which can be written as this. The N outside of the bracket is referring to the fact that we are looking for the number of elements in the set, not the list of elements itself. Now we are done with the parameter. Let's write what we do know for now. We know that the total numbers of players involved in this badminton competition is 38. The numbers of members play in double event is 20 and the numbers of members playing in single event is 26. If we were to try to illustrate it in a Venn diagram, it would probably look like this. Of course, it doesn't have to be a circle. It can be a square or a triangle or whatever shape you prefer, just as long as the overlap area is reasonable to the question given. Then the number of elements for the intersections of sets S and D, or in other words, the number of players playing both single and double event, is the overlapping part over here. The number of elements on the left would be the total number of elements in set S minus the number of elements in the intersection of sets S and D. This is because we already wrote and take account of the numbers of players playing both events from this intersection part over here. So to avoid double calculating them, we need to minus it from this side and as well as the right side. Next is to try to derive a mathematical equation from it, which is the universal set or the total numbers of players involved equals to the number of elements in set S plus the number of elements in set D minus the number of elements in the intersection of sets S and D. Now we can just substitute in the number and calculate it to get the answer, which is 8. Hence, the total number of members that play in both events is 8. The equation is basically derived from the Venn diagram. If you find it hard to visualize the Venn diagram in the future, you can just memorize the equation because it should be the same if there's only two sets. Alhamdulillah, that is all from me. Thank you so much for watching. Don't forget to like and subscribe if you find this helpful. See you in the next video. Bye.